All right. So chain rule is basically
Um, I'm sorry, Professor, but I was just letting you know that I was absent yesterday because our Wi-Fi was not working, but now it's good. But I'm still absent. Am I count as absent for for the Tuesday class?
I mean it's uh it's just for extra credit. It's not a count against you.
The absence?
The absent, no.
Okay, but I would appreciate it if you fix that, please.
All right, I'll think about it.
Okay, thank you.
Hmm. We can talk about it after. Okay. Um, Chain rule has is based on composites. So basically, if you see a function within a function, which can be almost any type if you look hard enough, um, the derivative. So let's say we let f of x and we don't need the comma and g of x be continuous and differentiable functions if y of x is equal to f of g of x, then the derivative y prime is equal to the derivative of the outside times the derivative of the inside. Okay. So for example, let's find one. This is number 5. Let's use the same notation. I'm going to rename it. Find the derivative of y of x. It's all good, man. Okay. So the function is equal to 2 times 5 minus 7x to the 5th. So the derivative is equal to the derivative of the outside. So the outside function is basically 2 to some x to the 5th. The inside function is equal to 5 minus 7x. That's kind of how I want you to think about it. This outside function is a 5th power function, and I'm putting this inside, hence a composite style. Does that make sense? So the derivative, yeah, dy dx of y, we can use that notation too, would be derivative of the outside. So you bring down the 5. subtract 1 and then multiply by the, you know what, let me put this in the next line so it's prettier. Okay. Load my elbowed my mic real hard. Okay, so 2, bring down the 5, then subtract the 5 by 1. So that's just standard power rule. Then times the derivative of the inside. Okay. So now this becomes 10 times 5 minus 7x to the 4th. Derivative of this is negative 7. Okay, which would be negative 70 times 5 minus 7x to the 4th. Do you see how we use the rule, right? Identify the inside, multiply by its derivative. Derivative of the outside is the outer function. This is the derivative of the outer right here. And then times the derivative of the inside. And you can have multiple functions within functions. So the chain rule could be, you could have a long chain, like more than 2 or 3, but at most, I think in this class, you'll probably only see 3. But you could have a ton of them. Any questions on number 5?
The y prime of x equals 2 times 5 times the 5 minus 7x to the power of 5 minus 1. Where did we get the first 5 from after 2?
You're doing the power rule on the outer function.
Okay.
Bring the 5 down.
Okay.
Subtract by 1.
Okay, got it.
And then times derivative of the inside. So this whole thing is y prime.
Okay, thank you.
If y of x is equal to f of g of x, then y prime would equal to the derivative of f of g of x. I don't have space. Then dy dx would be equal to d dx of f of g of x times d dx of g of x. There you go. Okay. So next example. I'm going to call it again y of x. Question first. Find the derivative of the function y of x will equal 9x minus actually plus 4 times 2/3, or to the 2/3. So dy dx is equal to the derivative of the f function times the derivative, I should say, you know what, let me make sure that notation is correct. 1 second. Something bugs me about it.
Would it be a dy dx equals dy du times du dx?
Yeah. Yeah, that's right. Yeah, if we label u as g, then yes.
But that would be the Leibniz notation, or I don't know how to pronounce the last name, but
Yeah, and whenever you have dy dx, it is Leibniz. So let me rewrite it because it is important to. We're not going to use it much for chain rule, but we will use it, I think, in the next section a lot. So let's fix this. So if, yeah, let me redo this part. I'm sorry. We'll just do this in the next page. Not enough space anyway. If y is equal to f of g of x, and we let u equal g of x, then it's not freezing, dang it. Dy dx will be dy du times du dx, which is essentially what we wrote earlier, but this is more proper. So that way we're using the chain rule in this notation. It's easier to learn the chain rule using this notation the first couple of times. But eventually we're going to move on to, especially in the word problems, we're going to need this. It's better. Okay. Anyway. Yeah. Essentially, A, that's pretty much what it would be. Same thing. Number 6. Find the derivative of, again, I'm going to use y of x. That's what we did earlier. Of 9x plus 4 to the 2/3. So our outer function f of x, they call it in the book f of u, but it's all good. This would be the outer part. The inner part is the g of x, which will be 9x plus 4. Okay. Okay. So the derivative, well, let's do the other notation first one more time. The derivative of x is equal to f prime of g times the derivative of the inner function. So here we'll have the power rule for the outer function. Track 1, right? Times the derivative of the inner function. So that'll be 2/3 9x plus 4. No 2/3 minus 1 is a negative. Third derivative of this will be 9, right? So at this point, just do some algebra and you're good. This would be 18/3 times 9x plus 4, negative 1/3. So fix the negative. That will be 6. Over 9x plus 4 to the 1/3. Are there any questions about these first two examples? Okay. Okay. And the first in the question at the beginning of the homework, they give you a table and they want you to label everything. They say the first part is your composite piece. the inner part will be u. And they just call y equal to f of u once you've replaced the, oh shit, I wrote that wrong. Dang it. Tired today. Okay, extra tired or something. Okay, so the inner part becomes u, therefore this is now f of u. Okay, so they ask you, well, what is the inner part? Obviously, u would be equal to 3x minus 7, right? Now that you've replaced the inner part with u, that means that y would be equal to u squared. So when you set it up this way, it's a little easier to use the Leibniz notation. So finding the derivative, they didn't ask us to do it, but if we want to find dy dx, right, that would be equal to the derivative of y with respect to u times the derivative of u with respect to x. So just go ahead on the side and find those real quick. dy du would mean take the derivative of y with respect to u. So that would be 2u, 2 minus 1, 2u, right? Du dx would be derivative of u with respect to x, so that would just simply be 3. So plug them in, then you're good. dy du, that'll be 2u times 3. So that is 6u. So bring back what u is supposed to be. That'll be 6 times 3x minus 7. Make sure you're comfortable with Leibniz and the prime notation.
Professor, can you go over how you get the 3 for the dv over dx?
So this is a u. So this is u right there, right?
Mm-hmm.
So the derivative of this, that's what this means, right? Du with respect
Okay.
to x would be the derivative of this with respect to x.
Okay.
So that would be 3, right?
I'm kind of confused
About?
because I didn't get how it's the derivative 3.
What's the derivative of 3x?
3,
And derivative of constant?
0.
So the derivative of u
Oh,
with respect to x
okay.
is 3.
Okay. Got it.
Yeah, if you showed the work, it'd be du dx d dx of 3x minus 7, which is 3. Okay. Any other questions on the chain rule for the first 3 problems? All right. So let's look at harder versions of this. So basically, when when you're doing the chain rule, you can sometimes have a quotient or a product rule trigger, and life sucks. So for example, when you try to do this derivative, number 10, it's going to be a chain rule, but when you do the derivative of the inside, you have a quotient. And number 11, this is a product rule, right? You have an x squared times a square root thing, two different functions. This is a product rule, but while you're doing the product rule, you're going to have a chain rule happen. Does that make sense? All right, let's try it out. Okay, let's try out the they both suck, so quotient one, I guess. So we got an outer function equal to just x squared. Inner function 1 over x minus 3. Stay consistent here. Yeah, let's just keep it simple. I don't want to mix and match too much. So the outer function we'll just call f. The inner function we'll just call g. Keep it simple. So the derivative using the basic prime notation is equal to, bring down the 2, subtract 1, times the derivative of the inside. No, sorry, I'm on crooked. Okay, so this will be a quotient rule, right?
Yes.
Times, let's figure that derivative out. Oh, for sure we square the bottom. So double check. I'm pretty sure it's f prime g, but I don't want to mess it up. Yeah. So the derivative of the top times the bottom minus the top times the derivative of the bottom. There you go. So the derivative of a constant is 0, so that's just going to 0 out. 0 times this. Minus the derivative of this will be a 1, so that'll just be a 1 times a 1 over this nonsense. So that's not all that interesting, but it wasn't, could have been worse, right? So we got 1 over x minus 3 times negative 1 over x minus 3 squared. So the answer will simply be negative 2 over x minus 3 cubed. You guys cool on number 10?
Yes.
A quick example. Think I gave this to you as a formula, but it comes from the chain rule. So we said that if y is equal to e to the kx, where k is just a number, real number, then the derivative would be that number times e to the k x. So this is because of the chain rule. So you can do the chain rule, or you can just do it this way. Alrighty. Let me show you the homework. So as you can see, here you're doing a quotient, but you'll have a chain rule trigger. Here's same type of deal. On 15, they ask about slope of the tangent line. So basically, find the derivative, plug in this x value. So stuff you've done before. It's just that now the derivative is using the chain rule. Let's do a trig type. And then I'll let you practice and see if you get any issues here. Also need to upload some videos back then. So y of x is equal to cosine of 3x. The outer function is the cosine. The f of u or f of g, however you want to think about it, don't matter to me. That's the cosine. The inner function is the 3x. Derivative of cosine becomes negative sine of 3x. So derivative of the outside, derivative of cosine is the outer function, negative sine, then times the derivative of the inside, which is just going to be 3, right? All right, so let's stop here. So try out chain rule for a bit. Let me know if you get stuck. So it's 9 o'clock right now. Let's try it out till at least 9:30. Pause here.